Hello everyone. The problem that we're going to be solving today is Pacific Atlantic water flow. This is a classic graph problem and let's just read the problem. There is an M cross N rectangular island that borders both the Pacific Ocean and the Atlantic Ocean. The Pacific Ocean touches the island's left and top edges, and the Atlantic Ocean touches the island's right and bottom edges. The island is partitioned into a grid of square cells. You're given an m cross n integer matrix heights where a height set each row and column represents the height above the sea level of the cell at coordinate rc. The island receives a lot of rain, and the rainwater can flow into neighboring cells directly north, south, east, and west. If the neighboring cell's height is less than or equal to the cell's current height, water can flow from any cell adjacent to an ocean into the ocean. Return a 2D list of grid coordinates result where result at I is equal to RICI, that denotes rainwater can flow from cell RICI to both the Pacific and Atlantic Oceans. So, so, so what they're saying is that we have Pacific Ocean here and Atlantic Ocean here. Water can flow into the Pacific Ocean from these cells, from the cells adjacent to the Pacific Ocean, and into the Atlantic Ocean from these cells. Right? These numbers represent the height above sea level, and it is but obvious that water can only flow from a higher level to a lower level and not from a lower level to higher level. This is not happening, right? It is basic gravity. So what do we need? We need the list of cells. We need the list of cells, the coordinates of the cells from where water can reach both the Atlantic Ocean and the Pacific Ocean. Now, what is the first thing that comes to your mind? I've said this many times. Graph whenever graph is involved, you only think about DFS, BFS, or union find. Now here union find is out of the question, so we can work with both DFS and BFS, because union find is just about the parent, right? Here we do not need to find any parent as such, but we need to instead loop through each element and see where can the water go. So we can either use DFS or we can use BFS. So let's just use DFS. So essentially what we need, so like let's say with an example, this cell can go directly into Pacific also, this cell can go directly into Atlantic also. So we mark this, we need this. Now this cell, from this cell water can directly flow into Atlantic. From this cell water can directly flow here, and from here to here, and from here to Pacific Ocean. So it can go to both Atlantic and Pacific, so we need this also. So now from this here it can flow to Atlantic because same height, and it can flow to Pacific because lower height. So this also we need. Now let's say this cell can flow to Pacific Ocean because lower heights, but it cannot flow to Atlantic Ocean because there is no path, it cannot go to a higher. These operations cannot happen, water cannot go upstairs, right? So this won't be our answer. So we need to essentially run a DFS wherein we are checking for the lower height, and we are not visiting the lower height, we are only visiting the same or the higher height, right? Oh, I said reverse. We need to check for higher height, and we are not visiting the higher height. We are either going to the same one or we are going to the lower one, right? And if it reaches here, if it reaches anywhere here, we can visit the Pacific Ocean. If it reaches anywhere here, we can go to the Atlantic Ocean. So basically the first thing that comes to your mind is have some data structure which stores the list of coordinates that can visit the Pacific Ocean and a list of coordinates that can visit the Atlantic Ocean. Atlantic Ocean, right? We can save this somewhere, and then we can compare the list of coordinates, compare the list of coordinates and return the common ones, and return the common ones. So now we can do that for each cell. We have to go through each cell, we have to go through each cell and find out where the cell leads, where the cell leads. So like if this is reaching Atlantic Ocean, we can save it in Atlantic. If the same is reaching Pacific, we can save it in Pacific. If the same is, and then finally we check for all the common ones and then we return, right? So now this is a correct approach, I must say. This is a correct approach, but we're doing a lot of repeated work. How? Lot of repeated work is being done. Let's say for example, this is going to the Atlantic Ocean, it is going to the Pacific Ocean from here, from here, that is from here to Pacific. So it is but obvious that we have done the job for this cell also, because while running the DFS we are seeing that this is going from here to Pacific. So we for running, while running for this, we also know that this and this are going into the Pacific Ocean, so we can cache it, so that whenever we come from this, we already know that it is in Pacific. We just need to check for Atlantic, right? So we need to cache, we need to cache, we need to cache results, cache coordinates, right, in order to save a little bit of time. So let's just have a dry run, let's just have a dry run. Okay, so this is a bigger one that I have saved. Let me do this. So we first have a set of Pacific coordinates and we have a set of Atlantic coordinates, So what are we gonna do? Like, we cannot go to each and then check whether it is going down, right? Instead what we can simply do is we can loop through this and this rows together and run DFS for each, and then reverse the condition. Right now what they are asking us to do is go from top to bottom, but we can do the reverse, right? We can start from the ocean and go upstairs. That is what we're going to be doing. It will be much more clearer when we write the code down. So essentially we'll be starting with this and this. So we are checking for Pacific here, Atlantic here, then we'll be going for Pacific here, Atlantic here. Okay, so now let's just go with this. Let's run a DFS here. So there you go. Now we start with 1. Now we need to go upstairs. First of all, does 1 go here to the Pacific Ocean? Yes, 1 does go into the Pacific Ocean. What are the coordinates of 1? Coordinates of 1 are 0, 0. So yes, 0, 0 goes into Pacific Ocean. Now we run a DFS. 0, 0 goes into the Pacific Ocean. We are adding it into the set. Now we go to its neighbor which is higher than it, right? We are reversing the condition. So we go to this neighbor first. We have 2 neighbors, right? We go to 2. 2 is 0, 1. 0, 1. Does this go into the Atlantic Ocean? Yes, it does. So we add 0, 1. 0, 1 here, higher or equal? Again the same thing. 0, 2. 0, 2. 0, 2 higher or equal? 0, 2. 0, 3. 0, 4. So higher or equal? 0, 3. 0, 4. Again higher or equal? higher or equal 0 4. This is what is this? This is 1 0 1 1 1 2 1 3 1 4. This is 2 0 2 1 2 2 2 3 2 4. So now higher or equal, we were here, higher or equal, does this go into the Pacific Ocean? Yes, it does. Does this go into the Atlantic Ocean? Yes, it does. Atlantic Ocean? Yes, it does. 504 goes into Atlantic Ocean as well as Pacific Ocean. Right? Now, now we backtrack because we are doing DFS. We go here. We go here. Higher or equal? Higher or equal? Higher or equal? Higher or equal? And this, we are not going here. We are not going here. So we will be adding. So we will be adding 1 3 1 4 1 4 because 1 3 goes into Pacific because it is coming from the Pacific side. It is coming from the Pacific side. It is coming from the Pacific side. Then this 1 4 1 3 1 4. Then again higher or equal? No. Higher or equal? No. Higher or equal? Yes. Now since 1 3 is already there, we do not add. We have 1 2. We add 1 2. We add 1 2. We add 1 2. And then we again backtrack. We have this. We did this. Now we again backtrack to 2. Higher or equal? We have 1 2 already in our list. So we go higher or equal. We add 2 1 to our list. 2 1 to our list. Then again 2 1. Higher or equal? Higher or equal? So higher or equal? We go to 2 2. We add 2 2 to our list. Then from 2 2, higher or equal? No. Higher or equal? No. Higher or equal? No. Higher or equal? No. So this is done. Then we go to 3 1. We add 3 1. We go for higher or equal. Any side? No, no, no. There is no higher or equal. So essentially this is how we add for every Pacific on this side. We add every Pacific on this side. And then we run the same thing for Atlantic also. We run the same thing for Atlantic also, and it will have some of them which have the same coordinates. Let's say 0 4 1 4 1 3, and then we return the coordinates that are common. We return the coordinates that are essentially common. So now let us quickly code this up. Let us quickly code this up. Let us quickly code this up. Right. So firstly, what do we have? We have int m is equal to heights dot length. Int n is equal to heights at 0 dot length. Then we have boolean array Pacific is equal to new boolean m times n. We have one for Atlantic. We have one for Atlantic. Then we go through this and this. That means we are going to the first row and column. First row and first and last rows for Pacific and Atlantic respectively. Okay, so 0 for int I is equal to 0, I is less than m, I plus plus, we go through DFS, I comma 0 comma Pacific and heights We will do the same thing for Atlantic, but this time with m minus 1. My bad, for n minus 1. We do this for n minus 1 because we are going at the last row, essentially. Last column, last row. So there you go. Now we're doing this for int j is equal to 0, j is less than n, j plus plus, and j plus plus, we do DFS with 0 comma j comma Pacific comma heights, and we do the same for j but m minus 1 m minus 1, but this time for Atlantic. And then finally we create our list of integer. List of integer answer is equal to new array list of integer for int I is equal to 0, I is less than m, I plus plus, int for int j is equal to 0, j is less than n, j plus plus. If Pacific at I comma j is equal to Pacific at I comma j, or not equal to, let's just say and, because this should be true and this should also be true. Atlantic. So basically if we are doing equality, it is also doing checking for false conditions, right? So if it is present in both, then result answer dot add arrays dot as list I comma j, and then finally we return our answer. Now let's just quickly code up the DFS problem. The public void DFS public void DFS intro int call boolean visited int oh my god, int heights, and then int heights we visited at row comma call is equal to true. That means if we are going there from any point, that means for the particular, let's say Pacific is being passed, that if we are visiting there, that means it can go to the Pacific Ocean. Now let's just have int directions is equal to 1 comma 0, or let's just say 0 comma 1. Let's just have it in order. 0 comma minus 1, 1 comma 0, and minus 1 comma 0, right? This then for int d in directions int new row is equal to row plus d at 0, int new call is equal to call plus d at 1. Now we check whether new row and new call are in bounds or not. New row is greater than equal to 0, and new row is less than heights dot length, and new call is greater than equal to 0, and new call is less than heights at 0 dot length, heights at 0 dot length, and not visited. Like if it is already visited, then there is no point on visiting it again. We are caching the result, right? Then and finally the last condition is that the heights at row and call should be less than equal to heights at new row, new call. That means it should go upstairs. We're doing the reverse logic. So now keep a note that this order is very important, because it should first check for bounds, then check for visited, then check for the heights. Because if it is not in bounds and we are checking this first, then it will throw us an exception. So if this is happening, then we can easily do with new row, new call, visited, and heights. We can easily do this. Let's just run it. Oh my god, my Wi-Fi is not working. So that's because the phone came in between. Anyways, does not really matter. My Wi-Fi is connected. Let's just run this and hopefully this works. Okay, we have an error. Oh wow, you're submitting too frequently. Leetcode premium. Oh my god, they want money from us. So again, public void. Oh my god. So our test cases have passed. Let's just submit and see whether it is getting submitted or not. Hopefully it does. And there you go. Areva. There you go. My complexity, my problem has been accepted. So I hope you all understood this problem. So essentially what we are doing in this is that we are running a DFS from each element that borders the Pacific Ocean, and the Atlantic Ocean, and we are saving them in a set. Or we are marking it as visited. We are marking those cells as visited from where you can reach the Pacific Ocean, or from where you can reach the Atlantic Ocean, and then finally you are returning the common ones. I hope you all understood the problem, and that's it for this video. Thank you so much for watching.